An equation is a balance statement. The equals sign says the expression on the left has the same value as the expression on the right. To solve, isolate the variable while preserving that balance. Whatever operation you perform on one side must be performed on the other. In this lesson, you will solve one-step and multi-step equations and check solutions by substitution. If x plus 7 equals 19, subtract 7 from both sides to get x equals 12. If x minus 5 equals 9, add 5 to both sides to get 14. The goal is not to move a term magically across the equal sign. You apply an inverse operation to both sides so the equation remains true. If 6x equals 42, divide both sides by 6. The result is x equals 7. A coefficient is the number multiplying the variable. When the coefficient is a fraction, multiplying by its reciprocal can isolate the variable. Always preserve the sign. If negative 4x equals 20, dividing by negative 4 gives x equals negative 5. If x divided by 5 equals 8, multiply both sides by 5 to get x equals 40. If x over negative 3 equals 6, multiply by negative 3 to get negative 18. Division equations are still balance equations. Clear the division using the inverse operation, then check that substituting the result recreates the original quotient. Solve 3x plus 5 equals 20. Subtract 5 from both sides to get 3x equals 15. Then divide by 3 to get x equals 5. Work in reverse order of operations because you are undoing the construction around the variable. Show one operation per line to reduce mental load and sign mistakes. Solve 5x plus 2 equals 2x plus 17. Subtract 2x from both sides to get 3x plus 2 equals 17. Subtract 2, then divide by 3. The solution is 5. You could move the smaller variable term or the larger one. Choose the direction that keeps the coefficient positive when possible. Solve 2 open parentheses x plus 3 close parentheses equals 14. Distribute to get 2x plus 6 equals 14. Subtract 6, then divide by 2, giving x equals 4. If both sides contain grouping, simplify each side first. Trying to isolate x while parentheses remain can create incorrect operations or missed terms. For x over 3 plus 2 equals 7, subtract 2 first to get x over 3 equals 5, then multiply by 3 for x equals 15. In equations with several fractions, multiply every term on both sides by the least common denominator. Do not multiply only the terms containing fractions. The balance operation must affect the entire equation. If simplifying produces 5 equals 12, no value of x can make the equation true, so there is no solution. If simplifying produces 7 equals 7, every value of x works, so there are infinitely many solutions. These outcomes often occur when variable terms cancel. Do not invent a value after the variable disappears. Interpret the remaining statement. For 5, x plus 2 equals 27 and x equals 5. The left side becomes 25 plus 2, or 27, which matches the right side. Checking the original equation is stronger than checking a partially simplified line, because it can reveal an earlier distribution or copying error. It also confirms signs and arithmetic. Common mistakes include subtracting a term from only one side, dividing only part of an expression, and changing signs without an operation. Fractions and negatives require slower notation, not a different method. Keep the equal signs aligned down the page. Each line should be equivalent to the previous line, creating a visible chain you can inspect. Use a stable sequence. First, distribute and combine like terms on each side. Second, choose one side for variable terms and the other for constants. Third, use inverse operations until the variable stands alone. Finally, substitute the solution into the original equation. The steps may vary in number, but the balance principle never changes. A written check also shows whether the final value answers the original equation rather than only a simplified intermediate line.